Good morning, students. Today we are going to start 50 unit in distributed systems. The unit is distributed file systems. Okay, this unit mainly deals with the file system and different types of file systems and what is peer-to-peer system and everything. Coming to the first one, DFS. We need to know about the DFS. Okay, we know about file system that we have learned in Unix operating system, that we have learned in normal operating system. Coming to the distributed file system, these distributed computers are located at different places and those computers are networked. That means those systems are connected. How these systems are using the file system? Coming to the distributed file system, it will enable the programs to store and access the remote files exactly as they do local ones. Like normal files in a local system, normal files will be we store some data. Okay, by using remote access also, it will works exactly like local ones and allowing the users to access the files from any computer over the network. Okay, suppose one file is at another system which is located at another place. We are at our system. Now we can access the file which is located in a different place in a different system. Still, that is possible by using a distributed file system. Okay, here we are having some challenges in this distributed file system. That is, we have some performance issues and we have some reliability issues. Okay, why? Because we are accessing the file which is not in our local machine. Okay, that was located at different place. Okay, some performance issues and reliability issues may comes into the picture. Okay, coming to the file system, were see the point here. The file system were originally developed for centralized computer systems and desktop computers. Mainly, the file system was an operating system facility providing a complete programming interface to the disk storage. Okay, file system is like an operating system and it provides a facility for convenient programming interface. Okay, providing a convenient programming interface to the disk storage. Okay, next point. The distributed file systems support the sharing of information in the form of files and hardware resources in the form of persistent storage throughout an intranet. See, the distributed file systems support the sharing of information among the networked computers in the form of files, and this is for software resources. Coming to the hardware resources, that are in the form of persistent storage throughout an intranet. Okay, throughout an intranet. That was not possible in the internet. It was possible on the intranet. Next point. A well-designed file service provides access to files stored at a server with performance and reliability similar to and in some cases better than files stored on local disks. This point is stating that normally we are accessing the files which is in our local machines. Okay, so sometimes we are accessing the files which are at server. From server we are accessing the files. This point is stating that accessing the files at remotely, that was in the server, is better than the local files accessing. That was meaning of this point. Next. Next is fourth point. The sharing of resources is a key goal of distributed file systems. Why? Because the resources that in the distributed system, the resources are shared among the systems. Okay, our key goal here is sharing the resources. That was the main goal of distributed systems. The sharing of stored information is the most important aspect of distributed resource sharing. Okay, why? Because the file or the content is stored at one place, that will be accessed by other machine at other place. Okay, this is called as resource sharing. Coming to the next point, the requirements for sharing within a local computer, local network, and intranet lead to need of different type of service. Okay. Here we are sharing the resources which is in the local within the local network within the intranet is lead to different type of service. The first one is it supports the consistent storage of data and programs of all types on behalf of clients and the consistent distribution up to date data. That means the data or the files are stored at one place. Those files are accessed within the intranet or within the local network. Those files needs to be updated up to date. Okay. Next point. The file service enables the programs to store and access the remote files exactly as they do local ones, and allowing the users to access their files in form of computer in the intranet. Okay. Here, a distributed file system enables the programs to store and access the remote files exactly like the local files. Okay. Next, last but one. Coming to the Java remote object invocation in Corba and ORBs provide the access to remote shared objects, but neither of these ensures the persistence of the objects. Okay. See, these are the different type of systems we are having. First one is the main memory. Second one is the file system, distributed file system. For main memory, sharing is not possible and persistence is not possible, and distributed cache is not available. Distributed cache, or it is also sometimes called as replica, and consistency maintainable is possible. The example for main memory is RAM. Okay. Next, normal file system, that is sharing is not possible, persistence is possible, the distributed cache is not possible, and consistency maintenance is possible. Example, Unix file system, normal file system. Coming to the distributed file system, see here in the distributed file system, the main point is sharing is possible, persistence is possible, distributed cache and replicas is possible, and the consistency maintenance is possible. Example is Sun network file system. The example for distributed file system is Sun network file system. Next one, web and distributed shared memory, remote objects, and persistent object store. These are the several systems in which we are dealing with. Just this is for your information, where here we are dealing with these 4 points, that is distributed file system. In web, the sharing is possible, and the remote objects. Okay, for the remote objects, the sharing is possible, and the persistent object store where the objects are present. Here also the sharing is possible. And last one is peer-to-peer storage system. In this system also the sharing is possible. Coming to the next topic, that is consistency. Here the types of consistency is strict one copy, slightly weaker guarantees, and the consistency is weaker. Okay, in distributed file system, the consistency is strict on one copy and slightly weaker guarantees and considerably weaker guarantees. That means we are not having that much reliable on distributed file system. Okay, moving to the next topic, that is characteristics of normal file system. Okay, this already we have discussed in operating system and as well as Unix. First one is for the file system characteristics. File systems are responsible for, we know, for storage, for organization, for retrieval of data, naming and sharing and protection of files. Okay. Second, they provide a programming interface that characterize abstraction, freeing the programmers from concern with the details storage allocation. Okay. See, the first point is for creation of file and organization of a file, storage of a file, naming a file, sharing a file, and protection of files. First characteristic. The second one is the files are stored on disks or other non-volatile storage media. Okay, these disks and non-volatile storage media will provide the programmers to access the data. Third point is files contains both data and attributes. The data consists of a sequence of data items. The data consisting of a sequence of data items that are accessible by file operations. The operations will be like read operation, write operation, etc. Okay. Files will contain the data and attributes. The file data can be accessed by mainly two operations. One is read operation and write operation. Okay. Here, the attributes held a single record containing the information such as length of a file. See, coming to in the previous point, I told you file contain data and attributes. We know about the data, but what about the attributes? The attributes will be like a length of your file, the timestamp of your file, the type of your file, and the owner identity of the file. Okay, all these control information comes into the attributes. File attributes means file name, file type, etc. Okay. Coming to this is all introduction about the file systems. Okay. Okay, this is the file system module. In this file system module, we have defined an abstract model for basic distributed file service. Okay, basic distributed file service including a set of programming interfaces. Okay, see here. The first one is directory module. Okay, this directory module is related to file names and file IDs. Next, file modules. This file module is related to file IDs and file IDs to particular files. Next, access control modules. It checks the permission on operations requested. Suppose we have requested one operation, read operation, write operation on a particular file, this access control module will check the permission of the users which we are requested for an operation. File access module. Okay, on some files we are having read access, some files we are having write access. Okay, reads and writes for file data or attributes. Okay, next block module. Okay, it accesses and allocates disk blocks. Okay, last one is device module. Okay, this device module deals with disks and IO operations and buffering. Okay, this is the abstract model, what different type of modules and they will relate it to. See, these are see here we are, these are some file attributes. The length of your file, the file creation timestamp, read timestamp, write timestamp. That means when we are performing a read operation, that's the timestamp, and write timestamp when we perform the write operation, the timestamp, attribute timestamp, what a reference count, how many users they are they referred this file, that reference count, and owner of the file, and the type of file, and the access control list. You see, these are all comes into the file attributes category. Okay, file length, creation timestamp, read, write timestamp, attribute timestamp, reference count, owner, and file type. Lastly, the access control list. Okay. These are different type of file attributes. Now let's move on to the file system operations. Okay. Here, the following diagram shows the main operations on files that are available to applications in Unix systems. Okay, this is an example which is related to Unix system. These are the system calls implemented by the kernel. Okay. By system calls also we can perform operations on the files. Here, see Unix file system operations. The first one, fields open name comma mode. That means open the existing file with the given name. Okay. Second one, create name comma mode. It will create a new file with the given name. New file with the given name. Okay. Second, next one, status close fields. This will closes the open fields, open files. Count, read count and write count. Here, coming to the read, it transfer the n bytes from the file references by the fields file descriptor to buffer. Okay. Next, similarly for write operation also. Next, POS. That means POS means pointer to offset. It moves the read write pointer to offset. Next, status unlinked name. This will remove the file name from the directory. This will remove the unlinked space, unlinked, if you are given the file name, that will remove the file name from the directory structure. If the file name has no other names, it will be deleted. Okay. Next, link name 1 comma name 2. That means it adds a name 2 for a file name 1. That means name 1 comma name 2 means adds a new name, that is name 2 for a file name 1. That is nothing but giving a new name to the old file. Next, stat name comma buffer. It gets the file attributes and file attributes for file name into buffer. Okay, these are all some different some Unix file system operations. Okay, open, create, close, read write, lc, unlink, link, and finally state. These are, as of now, we have discussed about the file attributes and file Unix file operations. Coming to the next one, important one, distributed file system requirements. Distributed file system requirements. Here, from here, we are started our syllabus. Coming to the distributed file system requirements, the first one is transparency. Here we are having the file service, usually most heavily loaded service in the intranet. So it is functionally and performance is critical. As I told you in the previous screen, previous page, with respect to performance, it was very critical because the file system is heavily loaded. Okay, the design of file service should support many of the transparency requirements for a distributed systems. Those are access transparency. We need to have access transparency. Who are access to the files, and the location transparency, the mobility transparency, performance transparency, and the scaling transparency. All these are required for distributed file system. This is with respect to transparency. Coming to concurrency. Here, same file will be concurrently used by so many users. Here, the changes to a file made by one client should not interfere with the operation of other clients. Suppose, let's take an example. You and me both are accessing same files. I made a modification to the file which is accessed. But this change what I made here, that will not interfere in your file. Okay, because we both are accessing the same file, but I updated the file with my requirements, but whatever the updations I made, that will not reflect in your work. Okay, this is a well-known issue of concurrency control. Okay, replica. A file may be represented in several copies of its contents at different locations. Replica is nothing but a duplicate. Okay, same information will be located at different locations. Next, heterogeneity. Here, client and server software can be implemented for different operating systems and computers. Not homogeneous. The client and server are heterogeneous. Next one is fault tolerance. Here, the central role of the file service in a distributed system make it essential that service continue to operate in the face of client and server failures. Here, main role of this distributed file service is, okay, we need to provide essential service whenever the failure occurs at client machine and server machine. Okay, this is fault tolerance. Consistency. See, same directory and file contents in different clients at the same time. Why? Because different people or different systems are accessing the same information. For that reason, the consistency must be provided. Same directory and same file contents on different clients at same time. Okay, this is called as consistency. And last but one is security. Here the secure communication will be needed and the authentication also needed. Why? Because the file is distributed. That means the same file is accessed over the network by different users. Though the file must need a protection. That means it provides an authentication. Only authenticated users needs to be accessed that file. Last one is efficiency. A distributed file system should be accessed high performance. Okay. As I told you, it is having some reliability issues and some performance issues. Okay. The main requirement for this distributed file system is efficiency. These are all the requirements for distributed file system. Okay. Now coming to the next one, file service architecture. Here in the file service architecture, that offers clear separation of the main concerns in providing access to files. See here we are having three components. One is a flat file service. Second one is a directory service. Third one is a client module. Here see the relevant modules and their relationship is shown in the computer, shown in the figure. Those are, we are having a client computer. In the client computer, we are having some application programs, and this is the client module. In the server computer, we are having some directory services. This directory service will provide different files. Okay. These different files will be accessed by the clients upon the request. Here, flat file service. What is the meaning of flat file? Okay, let's take an example of a flat file. It is containing only a name and address list. That is name, address, phone number, all these things. That is called as a flat file. See here they mentioned this diagram shows the relationship between client computer and server computer. Client computer is having client module and application programs, and these are executed by the server computer, and server computer is containing some directory services and as well as some flat file services. Coming to the first one, flat file service. Flat file service is concerned with implementing the operations on the contents of files. Okay, this flat file service will implement the operations on files. Some may read operation, write operation, put operation, get operation, all these things. The unique file identifiers, that is UFID, are used to refer the files in all requests. Okay, every request is containing the UFID. Every request given by the client is having the UFID, that is nothing but unique file identifier. These are used to refer the files in all requests for flat file service operation. With the use of this UFID, each file has a unique among all files in a distributed system. Okay, see how it will be like. The flat file services will be like. See, read of field comma I comma n. This will give read a sequence of data up to n items from a file starting at item I and returns it in data. Okay, this is the meaning of read. Next, write a sequence of data to a file starting I, extending the file if necessary. Next, create field. It creates a new file of length and delivers one UFID for it. For every created file,
one UFID will be generated. Next, delete field. This will remove the file from the file store. Get attributes returns the file attributes for the file. Set attributes. Here we are setting the we sets the some file attributes. Only those attributes that are not shared in the figure. Okay, the previous figure. These are the different type of flat file services, and we are having some different services. Just you can look into that. And what is client module will consisting of? Here, the client module runs on each computer and provides the integrated service. The integrated service is nothing but flat files and directory. In the server machine, we are having two services, that is flat file service and directory service. See here, in this diagram, we have seen here in the server computer, we are having two services, directory service and flat file service. These two are called together called as an integrated service. Provides an integrated service as a single API to the application programs. For example, Unix hosts a client module emulates to full set of Unix file operation. Okay. Next one is access control. Okay, this is all coming to the access control. In distributed system implementation, the access right checks have been performed at the server because the server or PC interface is otherwise unprotected point of access file for accessing the files. Here, this access control is at server side. Next, directory service interface. Okay, this we'll discuss in next class. Thank you, students.